Today we're going to begin our review video of Chapter 3, Section 4, or Section 3.4. And as always, whenever we start a video, we start with the learning target for the day. The learning target for today is to identify and classify numbers in the real number system. So let's jump into some definitions here. First definition that we've got is a rational number. A rational number is a number that irrational number. An irrational number is a number that cannot be expressed as a divided by b, where a and b are integers and b is not equal to 0. So an irrational number cannot be expressed as a divided by b, where a and b are integers. Real numbers are the set of rational numbers together with a set of irrational numbers. Key concepts. An irrational number is a number that cannot be expressed as a fraction. Some examples would be the square root of 2. If you go to your calculator and you'd find the square root of 2, you see that it comes out on your calculator as 1.414213, and so on, so on, so on. It's a non-terminating, non-ending, non-repeating decimal, and it therefore is irrational. The square root of 3, if we take 3 and we take the square root of that, we get a number like 1.73205, and so on. Again, a non-terminating, non-repeating decimal, so that is irrational. Name all the sets of numbers to which the number 0.090909 belongs. If you look at 0.0909, it is a repeating number. It is a repeating, and it can be written as a fraction. We could go through the process to do that, and we would find out that it is rational, and it is, of course, real. Rational and real. Name the sets of all numbers to which 0.10, 0.10101010 repeating belongs to. It is rational, and it is real. Name all sets of numbers to which the square root of 25 belongs. Square root of 25, if I take that and punch it in my calculator, I get 5. So that is rational, it is real, and it is an integer. It is an integer. Let me see, there was one at the bottom of this. How about the square root of 64? If I punch that into my calculator, I'm going to get the number 8. So it is rational, real, and it is also an integer. How about the square root of 12? Well, when that's not a perfect square, so I need to work on that with my calculator. And I get 3.46411016. It is a non-repeating, non-terminating decimal, so it is irrational. It is real, but it is irrational. A little bit about our some of the rules that we've learned over the past. This is just a review. Remember commutative property in arithmetic. If you look at that one, I've switched the order from one side to the other, and of course that's what happens here. Anytime we switch the order, it is a commutative property. 5.1 times 2.8 is the same thing as saying 2.8 times 5.1. I simply switch the order, so again it's commutative. Associative property, you look at what's in the parentheses here compared to what's in the parentheses here. We've moved the parentheses, the order of the numbers stay the same, so this is the associative property. Distributive property, I've got 2 times 3 plus 5. Over here I've got the 2 times the 3 plus the 2 times the 5, so I've distributed the 2 over the 2 parts. So that's distributive property. 8 times 0 is 8 times 0, it's supposed to say 8 times 1 is equal to 8, so that's the identity property, because multiplying by 1 doesn't change it. The same as 7 times 1. Additive inverse here. If I add 4 to negative 4, I get 0. And the multiplicative inverse, if I multiply a number by its reciprocal, I get 1. Just a little review of our properties. We're asked to identify or to estimate the value of the square root of 8. Well, this to the nearest tenth. Well, as I start to work through this, I can actually go to my calculator and take the square root of 8. And it tells me it is 2.828. 2.828. And if I take the square root of the negative square root of 2, I get 1.41. I go out one more decimal point here, 42. 1.4142. And then graph these on a number line. So let me look at this on a number line. I've got 2.82. I'm going to go over here 2.8. It's going to go over to almost 3, not quite. And I've got a negative, because it told me to take the negative here, 1.4142. So it's a little bit more than negative, a little bit further to the left of -1. And it would be right there. So that becomes the negative square root of 2. This is, of course, the positive square root of 8. And which would be larger? Well, the square root of 8 is larger than the negative square root of 2. Same kind of problem here. I take the square root of 3, and that is 1.732. And I take the negative square root of 6, the negative square root of 6, just the square root of 6, and then I take the negative of that number, negative 2.449. I'm asked to place those on a number line. So I've got 1.732. It's going to be over here, close to 2, but less than 2. It's on the positive side. And I've got the negative 2.449. So it's negative 2 plus a little bit more, almost half. So this is the negative square root of 6, and that's the positive square root of 3. The positive square root of 3 is bigger than the negative square root of 6. So negative square root of 6 is less than the positive square root of 3. Here we're asked to replace this symbol with a correct sign. I'm going to change both of these to a decimal and then compare the decimals. So I've got 3 7/8 becomes 3.875. And I've got the square root of 15, again with my calculator. I've got 3.8729. Well, if I look at these fractions here, they're the same to the tenths place, they're the same to the hundredths place, but here in the thousandths place, I see that 5 thousandths is bigger than 2 thousandths. So 3.875 is larger than 3.872. So this symbol should be larger than 3 7/8 is larger than the square root of 15. Same kind of problem here, still 3 3/8, but here it's the square root of 14. So 3 3/8 is 3 3/8 is 3.375, and the square root of 14 is 3.741. Well, looking at this in the tenths place, this is 0.3, this is 0.7, the 0.7 is larger. So the square root of 14 is larger than 3 3/8. So 3 3/8 is less than the square root of 14. Similar problem, 3.2, but I need to work with the square root of 10.4. So on my calculator again, I get 3.2249 compared to 3.2. All right, 3 point, in the tenths place, they're the same, but this is larger than the 0 that's here. So it goes like that. 3.2 is less than 10 to the square root of 10.4. Same question kind of here down at the bottom. 1.5, but with a bar, compared to the square root of 2.25. 2.25 square root is 1.5. So on this side, I've got 1.5 with a repeating bar. And over here, I've got 1.50, no repeating. So this with the bar means that this is 5, 5, 5, 5, 5, and so on. So this side becomes larger. So 1.5 with a bar over the 0.5 is larger than 2.25, the square root of 2.25. The time in seconds that it takes for an object to fall d feet, that's the distance, d feet, is 0.25 times the square root of d. How many seconds would it take for a baseball that has hit 250 feet straight up in the air to fall from its highest point? Well, what they're telling me is this is my distance, so I'm going to substitute that in there. I've got 0.25 times the square root of 250. I'm going to take my calculator and get the square root of 250. And then I'm going to take that number, which happens to be 15.81. I'm going to take that times 0.25. And I get 3.95 seconds. I'm going to round that off to 4 seconds. It's the approximate answer. Similar problem, but this time it's hit to a height of 450 feet. Well, I still plug the 450 feet in for D, so I've got 0.25 times the square root of 450. The square root of 450, according to my calculator, is 21.21. I'm going to take 21.21 times 0.25. And I get 5.30 seconds, or just over 5 seconds.